Okay, I have no idea why our camera's doing this. Alright, well, it doesn't look like we'll be fixing anything until we get this camera issue sorted. So, I will be back momentarily. I have no idea what's up with this camera and why it's doing this nonsense. But it appears frame rate 0.7. Why is the frame rate so low? Alright, I'll be right back. See you guys back. Okay, hopefully this is better. It appears to be better. So to restart my computer. So apologize for that. We'll be back here and get into this board here in a second. This is an iPhone 6. Liquid damage, does not turn on, gets hot. Apparently, from what I've tested, it gets hot. I don't even have an iPhone charger around here, so that'll be interesting. I'm just gonna share the post on the groups. Then we'll get started. Video output low. If you guys are having issues watching, obviously 2 people watching, there has to be some issue. It's saying video output low. I'm not sure exactly why that's happening, so please let me know if it's buffering. I'm pretty sure it's buffering pretty bad right now. We dropped frame 0, so I don't know what the problem is. It's an iPhone 6. Okay, so it's still saying video output low. I don't know what's going on. If you guys are having issues with watching, let me know. But this is an iPhone 6. Does not turn on, as I said. Remember, we want to. I don't know what you mean by the microscope image is mirrored. So, let's have a look. Before we use our brain, let's just have a look at this board. And let's see if anything looks funny. So, see under here, this shield, everything looks perfectly fine. I don't see any issues near the PMIC. I think that's a PMIC. I have no idea what I'm doing with iPhones. This is not a customer's device, just to say that. This is one of my own. So, don't really see anything. Flip the board over, not much to see on the side. Oh wait, is there? Got some corrosion. But there's corrosion there, but what is that? That doesn't have anything. There's nothing here important. So that's irrelevant. So, no. Can you repeat the issue? It's an iPhone 6. It does not turn on with liquid damage. So let's go over here. Nothing much to see here. Haven't taken off this shield yet. Battery connector area. Everything looks good over here. Let's double check over here. Let's move down, shall we? So this board looks pretty good, doesn't it? I mean, no obvious signs of liquid, right? You can tell. What are you? You look suspicious. Zoom in on it. Those don't look very happy. Those guys do not look happy. Now, I don't have ZXW tools, so let's go to the board view. Let's have a look on the board view what those things are. Looks like a capacitor and maybe a resistor. PC main backlight. Well, we'll get to that, but I don't want to use my brain right now. Okay, we're going to try and fix this without using our brain before measuring. So let's go schematics. This is an 82034 something. 8203486A. So 3486. 3486. Let's look at the board view to get these component numbers. Where do you get schematics from? I don't know. Mystery. So it's going to be these guys right here. It says C4710RF. We're going to copy. We're going to look in the schematic and see what these guys do and what their value is. And my guess is, I'm hoping we could just knock these off. Let's go to the schematic now. I've never opened an iPhone before. I've really never worked on one. So this is my first attempt. Probably be pretty funny. Alright. So what is this for? PP BAT VCC. It's for, imagine something with the cellular service right here, right? PP BAT VCC. Okay? We have a short on these. I'm willing to bet that cap is shorted. That is just gonna pull down our battery reading. iPhone expert? No, I'm no iPhone expert. I have no idea what I'm doing. So obviously we're gonna have a short. I'm willing to bet we're gonna have a short. I mean, I don't see how we're not gonna have a short, but let's zoom in on these guys. And we're gonna say goodbye to these. Come on. And our other one, we'll figure it out, but just gonna measure. I already know this is gonna be shorted, and I already know that this is probably gonna work, and I have not pre-diagnosed this. I just gave it a little look over. That's it. I have not looked at the schematic. The first time I looked at the schematic was when you guys saw it, so hey, look at this. Yeah, goodbye. Goodbye. Now, I'm guessing we don't need this cap. Um, I'm hoping, I don't think we need this cap, but I'll try and find a 47 PF cap. This little guy next to it, I'll try and figure out what he does, but zoom out. Why not clean them first? Because I don't need to look to I don't need to measure that to tell you that's shorted. That's shorted. You know, there's no need to clean that. That, look how bad that looks. That does not need to be on the board. You know, pulling them off the board isn't really an issue. Just, you know, if something looks like that, you don't need to measure it. Just go, get out of the board, get off the board. Has no business being there, like looking like that. So, no, just goodbye. It could be the corrosion that's causing the short, but I really doubt it. I don't want that, something looking like that on the board. So this is a 47 PF. I do not have one of these. I'm sure I don't. Unless it's on an iPhone 5 board. So I have a couple iPhone 5 boards. Exactly. See how I just knocked it off with my lead. So an iPhone 5 board. Let's try and find a 47 PF cap, and let's look at what this other guy does. Come on. Where's my board view? Board view, iPhone 6. This is probably important. It's a 0 ohm resistor. This is probably important. So R4706 RF, and that's a 0 ohm resistor. Alright, so now we're going to get a parts board, and we're going to replace these. Now I could try and measure that resistor. That resistor didn't look all that bad. I doubt I have it, but no, it's worth a shot. So what I'm going to do is just if you're going to replace every bad-looking component on a water-damaged board, then maybe best to replace them all as you cannot see what's under the ICs. Okay. I'm not trying to sound arrogant here, but I repair liquid damaged devices, you know, very, very often. I know what the feel of a component that looks like bad. You know, I know by looking at a component what's good and what's bad. I could tell by the way those caps look. You don't see the pads under. Look at this. Well, it's gone now, but there was no pad under that. It's no good. It has no business being on that board. You will get the feel by just looking at it what looks good and what doesn't. You know, there is no way that capacitor is going to be any good after I clean it. The pad was burned. The pad under it was burned, okay? I can take a good capacitor with my leads and it's not going to come off. That capacitor, I just had to touch it with my lead. When I went to measure it, it knocked it off the board. Okay? That capacitor in no way was good. If there is no pad, then there is no short. No, there's still a pad there. Okay, there's still something there to make that connection. It's just not a good connection. Okay, you'll see after when I'm done cleaning it. I'm gonna turn my air way down because we don't want. If you can look at that and tell me this nozzle's way too big. Small nozzle. If you look at that and tell me that component is good, and say it just needs to be cleaned, then, you know, I don't know. That component in no way was good. And what is, you know, what is replacing a capacitor? How long does that take? It's not a very difficult task. You know what I'm saying? It's not a clean it first and make it. That wouldn't have stayed on. If I cleaned that, it would have fell off. You know, and that's pretty much the only corrosion I see on that board. Doesn't even need to be clean. When I'm putting flux down and resoldering it, it is going to be clean. So what I'm going to do is just touch up the joints on this one resistor. Well, I'm just going to give it a little reflow. And the resistor actually might be okay. I don't want to melt our antenna, but it's okay even if we do. Yeah, the resistor. Mark Prince, moving over to the dark side. Yeah, I am. Just for today. And that guy looks so he could stay on our board. He can stay on our board. But this other guy, okay. So to the person in chat that's giving me a hard time about replacing this capacitor, see right here, see the pad? Okay. When a capacitor looks like that and the pad under it looks like that, just, do away with it. It does not need to be on the board. This resistor looks okay to me. We're going to measure it just to make sure. But I'm pretty sure that cap is the cause of our issues. And Mark, you should be a mod here. So, I can still pull the other shields if it doesn't work. I don't want to. I think we'll be alright. No, that resistor is good, so it was just that cap. Now let's find a 47 PF 47 PF capacitor. That's going to be on one of these iPhone boards. These iPhone 5 boards, that's all I have. Let's open a schematic for an iPhone 5, and let's find a 47 PF capacitor on an iPhone 5. What board number is an iPhone 5? 820-3141. So an 820-3141. Schematic diagram. Let's look for 47 PF. Alright. So we have a 47 PF. This one will work. 16 volts, the same one. So C. Now it's going to go to the. We'll go to the component placement for an iPhone 5. Let's do a search and get out of here. We don't need a font package to display this properly. Search. See where you're at. I don't see where you're at. Alright. Looks like you're going to be no, honestly, I'll ultrasonic this later, but I never make note of damage areas then ultrasonic them. I always just jump in and fix them. You could say it's not the way to do it, but it's the way I do it here. And who cares if we have different ways of doing things? At the end result, Still gonna make it work again. Alright, so I have one of these things. So it's gonna be this little guy right here. Yep. Wait a second, I'm confused. Okay, it's right there. I get it. I have it. Alright, so we know where our donor cap is. Let me minimize this. Know where our donor cap is. It's gonna be right around here somewhere. So now what I'm gonna go ahead and do is so we know we have a suitable capacitor. Now let's go on this board and let's prep it. So to prep this, we're gonna have to figure out so that's just obliterated. Oh, this is gonna be fun with my iron, but let's see. Let's see if I can't. Kick on the fume extractor. Exactly. I'm not gonna debate over replacing a capacitor that costs, nothing. And I have them, so why not just put a new one on? So I'm probably gonna have to run a wire, unless we could find a pad. No. I don't know if. Just trying to figure out who's ground. I'm pretty sure. No, this is ground. So. T15 ILS. Okay. Alright, so we kinda. Regardless, I think we're gonna have to run a wire. Yeah, that's not gonna work. So let's figure out where that goes. I could kind of read the board. Let's see. I'm gonna probe around and let's look. Looks like it's on the same line. Let's clean it a little bit better so I can see. You guys probably can't even see a thing. It looks like we're gonna have to run a wire to that capacitor, from that capacitor to wherever it goes. But I think it's just gonna be a little jumper right to that resistor. Once we have pad there, let's just clean it up a little bit. These are nothing but, of course these are ESD safe Q-tips. Yeah, okay, so there's no way, you guys can't see the depth, but that's cratered under that. So let's go to the schematic. iPhone 6. Wait a sec. Find out where this cap goes. Guessing. I actually have no idea where this cap goes. Oh, so it's just on PP BAT VCC. Alright, easy. So let's just solder. This is an iPhone I bought for $30 on eBay that I want to learn how to fix because I have no idea what I'm doing with iPhones. So yeah, this really, this capacitor, this is pretty not needed. I don't know how to word it. So we're gonna leave it off for now. I mean, it's iCloud locked. It's not gonna matter. So let's put a shield on, plug this thing in. Have to go get a charger probably. Let's see if she works. So let's see. I think this shield can go right here. Yeah. Should I bother putting the shield back on? I'll probably buy ZXW if I could know how to fix, if I get proficient in fixing these things. I want to fix at least 3, before I move on to messing with somebody else's. But I feel like I can do iPhones. I mean, it's not really all that much different. No, it's not. There's minor differences, but it's not like going from MacBooks to iPhone. Like you're not going to be able to do it, I can't see anything. And if this doesn't work, then I'm probably going to come back later because I'll need to do some research and learn what I'm doing. But I'm pretty sure I'm pretty sure this is going to work. So. I'm about 90. Wait a second. We have our Wi-Fi, our antenna. It's a little stuck. We gotta get him out of here. Come on, free up. There we go. Oh wait, no, this goes on the outside. Major difference is the heat. MacBooks and pretty iPhones. Exactly. I watch my heat. I didn't. I remember on the first iPhone board I ever bought, I bought a 5. I used 430 and 100 Celsius, 120% air, and I would figure why is everything falling off the board? Why when I heat one side, why is all the components on the other side off the board? I figured it out. Can't treat them like MacBooks. Ow. Hot. Feeling the shield is off a little bit. No, I don't think so. No, you go back. Yeah, but I agree. The heat difference is makes a huge difference. I could take my Quick to MacBook and it's gonna be fine. But I can't do the same thing with these guys. All right, so we have our shield back on. All right. Now the enclosure. I'm gonna have to get a charger. So give me 1 minute. Let me at least put this back in the enclosure. Now maybe somebody could answer this. Oh, it's probably this thing. Somebody in chat, hopefully they could answer this. I don't see what the purpose of this thing is. Looks like it has 2 contacts. I don't know what it does. Unless it's it's a speaker. Okay, that's what that is. I was wondering, what does this thing do? Why is it here? So let's just set our board in. Now where's our... Oh, okay, I see. I was looking where... This is the first iPhone I've ever taken apart. The last phone I've disassembled was a BlackBerry. Board doesn't want to go in smoothly. What's keeping the board from going in smoothly? The shield? Yep. Alright. Gotta solder the shield better, it won't go in. Oh yeah, I cannot leave that like that. That would not be good. Alright. don't see why our board isn't just sliding in. Yes, I know, software corruption and a new battery. I don't care. It's, again, I bought it for $30. I don't care that the software is going to be corrupted. I just want it to turn on. There we go. Our motherboard in, sort of. I guess you could call that in. Don't want it to short on anything in the case, so I'm going to put one screw in. The main, this one bigger screw. Yeah, the label. I know what you're talking about the label mats, the iFixit ones. I'm pretty sure. It's a thought, but I'd have to do this more. I mean, I made like a little map in of the screws in my mat, so I think I'm all right. Good. Alright, whatever. The board almost looks warped. The board is warped. Huh. No. Yeah, the frame is warped. That's why the board won't go in right. Oh well, it'll be alright. I'm not going to put a screw in the board then. So the frame is warped. This is an iPhone 6. So I'm just going to plug the cables in. Wi-Fi antenna, we don't need that right now. Speaker, we don't need the speaker right now. Screen, we need the screen. Alright, so never dealt with screens before. I don't like dealing with general stuff. You guys are probably laughing at me right now. I'm sure the battery's going to be dead. So I'm going to go get a charger. Alright. Be right back. Alright, I can't use a power supply. I don't have the special cables. Alright, so moment of truth. What's gonna happen with this? Furthermore, did I plug in the... So far, nothing. Let's see. I probably missed a plug somewhere. Where does the... Wait, no, I have it plugged in. Oh, there we go. Alright. Try this again. Hopefully this works. Yeah, the boards do start to... on these. Let's see, come on. Plugged in for a second. Should come up right away, right, when you plug it in. And nothing. Let's see if the computer recognizes it. Let's see if I feel anything getting hot. Let's get my FLIR. We'll probably have to take off more shields. Nothing I see visibly getting hot. We have all of our plugs in. Good. Alright. We have battery plugged in. Could have bad battery. It should if and that could be our issue. TriStart could be bad. Plug it in one more time. Alright. Looks like I have no backlight issue or something. Nope. Alright, let's see if the computer recognizes it. I'm gonna lose Microscope for a minute here. I don't have iTunes installed either, so. Nope. Alright, so let's unplug the battery and try it again. Because I know a bad battery can make a MacBook not turn on. Maybe it can make an iPhone not turn on. Alright. Alright, I'll check that in a minute. I was really hoping this would just be, I haven't even taken up the other shield, so let's see. No, I don't have a USB amp meter. So no, this is not working. Let's see. Kind of heat. I honestly don't know. That was really the only spots of corrosion that I saw. Let's see. I should invest in power supply cables. No, I don't have anything for iPhones here, so this was just a little project that I wanted to try. So leftmost battery terminal. That's what I'm gonna check right now. I'm gonna unplug the screen because I don't think the screen needs to be plugged in for that. Okay, so you're saying the leftmost, so it's going to be this one, right? Oh, wait, my microscope camera, so I can't even show you. Yeah, I know that feeling about MacBooks. Only I'm clueless with iPhones, as you guys can see. There you go. Need power via USB, of course. I'm gonna put power via USB right now. Alright. So zero 0.64, 0, 0.17, 0.25, 0.3, 0.71. So I think you're talking about this one, and that's 0.64. So it could be a TriStar issue. Let's measure for short now. No short. The short here, I'm guessing this is ground. I'm guessing this is ground, this is your main power, and these are your signal lines right here. So yeah, so listen, so dead TriStar. Okay, where is that at now? Where on the board is a TriStar? I could look at the board view. I'm probably gonna have to take up that shield again. Alright. Bottom lower shield. Below the NAND, under the shield. The one I just took off. Of course. Alright, let's take this guy off and let's not go too hot. We'll do hot and fast. I think that'll be better. So 430, 120. 430 liters, 430 Celsius and 20. I'll have to order a TriStar too. I don't have any. You know what? It's underfilled and has overfill. That sounds fun. I have to change my nozzle. let's have a look. So TriStar, this little guy, I bet. So, let's see, I'm guessing it's this chip there. Yeah, I think so. I could be wrong. Yeah, it's the only thing that looks like a TriStar around here, so let's clean it off. And hopefully that's it. Given the fact that there was liquid under that one area, that's very probable that the TriStar got hit too. Or it's something coincidental, you know. That's the vibrator driver. Oh, okay. I see where it is. See what I mean? I'm clueless. That's your TriStar then. Let's get this overfill off. And to take the overfill off, I'm going to use 500 Celsius at 120 liters a minute. No kidding, 160. Board is hot. Yeah, that's the TriStar. I'm going to take it off today because I don't want to lose the orientation. No, I'm not getting this from a donor board. I'm ordering one from Lewis. Just want to make sure I get that orientation down, clean it off. And pulling this off will be even funner. Putting it on is easy, but let's get some alcohol and I'll be done for right now. So maybe somebody can answer this. How would the TriStar fail if it has underfill? And I know from a bad charger, but how would liquid make it fail if there's no if there's underfill and overfill on it? unless it's unrelated. Yeah, I'll come back to this. I mean, I'm not done. I'm gonna order a TriStar and then come back to it and get it working. So pretty much that's it for right now, and thank you all for watching, and I'll see you when I come back to this, probably next week. Thank you for watching, and I'll see you next time.